In this video, we're going to take a look at PAttach. PAttach is a dynamics operator that's going to connect one particle to another, and it's kind of like linking in regular Max so that it inherits all the rotation and translation of the source object. It kind of creates a hierarchy, but of course it does not really affect the group hierarchy. Anyway, let's go ahead and take a look. We've got this draw RGB rule out here. We're not using the green or the blue right now. What we've got is a draw red, where these three red particles are created. They are being given a velocity at birth, so they're going to kind of move up this way. And in the next rule, we've got a matter waves born, which is giving birth to all these blue particles on this plane object out here. I'm going to go ahead and hide that plane for now. And in the next rule, we've got the PAttach. This uses a P-pass-AB initiator, where in the group A we have the red and group B is blue, and any red who comes within 10 units of a blue, all those blues are going to be sent out on the B particle, and the red particle is going to be sent out on the A particle. And the way PAttach works is, you can see how we have it wired up here. We've got the A particle, the red, going into the particle from, and the B particle, which is blue, going into the particle to. It's really easy to see once you test and set these up that in order for this to work, and you can see this scrubbing over here, you can see these particles, the red particle picking them up and kind of holding them out in front. This is because as soon as those blue particles are within 10 units, they immediately start to inherit the translation of that red particle, its change in position. Now, if you read the help file, you may notice that it kind of says they should be the other way around, but you can tell immediately if you go ahead and crisscross these to switch them. What happens is, well, as soon as the reds get anywhere near within 10 units of these blues, those reds automatically attach themselves to the blue and they stop. So that's not what we want. We want the red particle to kind of control the blue particle. So we're going to have it set like that. And we're going to do something else to these red particles. We are going to give them some spin so we can kind of see what happens as they're spinning around. Go ahead and set their spin time to be 5, and a little bit of variation. Let's change our view around, and okay. So even though we can't see their shape, we know that red is spinning, and we can see that effect coming through on those blue particles. As the red spins, he kind of picks up those blues and twirls them around in a ball. Let's go ahead and we'll set that spin to be faster, and we'll actually also have, set the velocity, have them move faster. Okay, so this is kind of the effect of particle attach. It takes one particle and very much like a Max linking hierarchy. You see that link tool there, links him to him. So any which way that we rotate that source object, it rotates the child, and anywhere that we move the parent, of course the child's going to go as well. So this is what particle attach will do for you. Let's go ahead and take a look again at the operator itself. We'll go ahead and say visible all, and you'll notice that he does not have any parameters listed, and all we have is the on, so whether or not that attachment is turned on or not. And of course, if it's not connected, then it will be treated as on. And then also a time value, which really isn't going to play any effect because there's no keys over here to modify. And then we've just got the particle from and the particle to. And just remember from our little experience here that basically the particle from is the parent and the particle to is the child. And if you ever forget, you can always really quickly go ahead and reverse them, and you'll see that what you thought were the parents are not going to be doing a whole lot. So we'll go ahead and swap those back around. So just remember, particle from should be the parent, particle to be the child. unless of course we have PPass AB switched around. If we had the blue doing a comparison to all the red, well then this is going to be wrong and those reds are going to stop. So in that case you would have to switch it around. That shouldn't be too confusing. Just remember, whatever you have going on in PPass AB, those particle outputs are going to affect the from and the to. I normally like to have the initiator have the kind of the primary or main active, the particle of interest be in the group A, and all the others be in group B. So let's go ahead and extend this distance here a little bit. You can see that they go ahead and pick up all over the place. Something interesting just to play with it is the only use nearest. Only the nearest. What this says is, as the red particle is moving through space, he's going to compare himself when he comes into contact with any blue particles within 15 units, but he's only going to use the nearest one to output that pair. He'll output his red, and he'll output only the nearest blue in that time slice. So what this will mean for us here is that the PAttach is going to occur only at one particle at a time. And so what happens is those blue particles are going to be kind of lifted up and moved around, pushed around, but they're not going to stay attached to that red particle. Only the one closest to him is going to be using that attachment. Okay, we can easily solve that again by setting this to only the nearest. And if you want to experiment, of course, you could also turn on only the furthest. It kind of creates some funky results, but okay, so this is particle attach, and we'll go ahead and move on.